Welcome to More Learn, More Teach, where I attempt to simplify the complex. So now let's talk about some general graphing rules to help us with plotting feature graphs. So I have three rules I want to talk about. Let's say that I have g of x is equal to a times f of x. So I have some function, some known function that I have a known graph for. And now I want to multiply by some constant. Okay, if I do that, it will look, this g of x will look like f of x did, but now stretched in some way. Second, if I had g of x equal to f of x plus b, so I have some function f of x that I know what it looks like, but now I add a constant to this f of x, that's going to look exactly like f of x did, but now shifted in the direction of the g direction, right? So, or y, whatever, right? So the g of x direction, the y-axis, right, will now shift by b, this constant. Third, let's look at g of x is equal to f of x minus c. That's going to look exactly like f of x did, but now shifted in the by c in the x direction. So now let's use our f of x equal to x, or y is equal to x, like we had in the last example. Start with g of x equal to f of x equal to x, this line with a slope of 1 that has a y and an x intercept at the origin. And let's see how this shifts using these rules. All right, so let's look at the first rule. So g of x is equal to a times f of x. And again, we have g of x is equal to our f of x, which is equal to x. All right, so I'm going to have 7 cases based on what the value of this constant is. Let's do the 3 easy ones first. If a is equal to 1, g of x is just equal to f of x, which is equal to x. No change in the way the graph looks. Case 2, a is equal to negative 1. So now for every value where g of x was positive, now it's the same value but negative, and the opposite is true on the other side of the axis. So if I drew a perpendicular line, or a slope of negative 1 in this case, I would see that if g of x is equal to negative f of x, it just flips over the x-axis. So I just flip over the x-axis if a is equal to negative 1. You flip over the x-axis. If a is equal to 0, then there is no function. F of x is equal to 0 always, because anything multiplied by 0 is 0. Therefore, g of x would equal to 0 regardless of what f of x is if a were equal to 0. So these 3 cases are shown here, and we're going to use these to show the last 4 cases. All right, so let's look at the case where the value of a is some number greater than 1. So everywhere that f of x is a positive value, I have a number of a greater than 1. So I have now a bigger number. When f of x was equal to 0, there was no change. So my origin doesn't change. For every value of x, g of x is now bigger than it was. So I am now somewhere above this line. So I have rotated this line in this direction. I've rotated it in this direction. I've skewed it towards the y-axis. Okay, on this side, for every value of f of x is a negative value, I am multiplying by a constant that is bigger than 1, which means I'm going to get even more negative. So I'm going to be even more negative. I'm going to rotate in this direction. So you see the whole line rotates towards this y-axis. It rotates toward the y-axis. This is for g of x equals a of f of x equals ax, where a is greater than 1. So let's look at case 5. So now a is some value between 0 and 1. So it's still positive, some value between 0 and 1. That means it's a fraction, right? Some fraction. Well, if I multiply by a fraction, then the number is going to be smaller. For every value of x, I now have a smaller value because I have multiplied by a fraction. So I'm going to have, very similar to what I had last time, I'm going to rotate, but this time I'm going to rotate in the other direction. This is now g of x equals a f of x equals ax, where a is a fraction, is a number between 0 and 1. All right, so now let's look at the negative case. So in the negative case, I'm going to say that g of x is equal to negative a of f of x. So a is just some constant. But now that I've said that a is a negative value, I'm going to take the negative of this in order to apply my previous rules. So if I do that, now this quantity becomes a positive value, right? Because I have a negative times a negative. This a is some negative. So I have some value between, some value who is less than 1 for both case 6 and 7. So some value is less than 1, some negative value. So if a is a negative value and I multiply it by another negative value, I now have a positive value and I can use the same rules I had here. So if that's true, then for case 6, so I have a fraction, a negative fraction, if I use this rule, then I would expect that I will rotate towards the x-axis. And that's exactly what we have. So this is g of x equal to a times f of x equal to ax, where a is some fraction. If a is more negative than negative 1, so it's even smaller than negative 1, then I'm going to rotate the other direction. I rotate towards the y-axis. All right, so let's look at rule number 2. So here I'm going to have g of x is equal to f of x plus b. G of x equal to fx plus b. We have 3 cases here. Case 1, b is equal to 0. If b is equal to 0, there is no shift. So g of x equals f of x. In this example, is equal to x. Case 2, b is some positive value. So b is some number that is greater than 0. So everywhere along this line, for every value of x, I have a constant but greater number. So it's a constant number. So therefore, if I have some constant, let's say that I have some constant amount, it's going to be constant along the whole path. What that's going to have a tendency to do is shift us straight up by some So we shifted straight up by some constant. That constant is the value that was shifted, which is our b. Right? For case number 3, b is a negative number. So now I'm going to subtract a constant value. Right? Subtract a constant value. So once again, I'm going to have a constant. This is going to just shift along the g of x axis by the amount. So let's talk about the third rule. So this third rule is g of x is equal to f of x minus some constant. And we're going to see how that's going to shift along the x-axis. Think of this more as a delay, right? A delayed start. So again, we're going to have the 3 cases, right? Case 1, there is no shift, right? C equals 0. Case 2, some positive value. So think of it like a positive delay. So at some x value of c, so at some x value of c, that's when we start. So if you look here, if x were equal to c, f of x minus c would be f of 0, right? So this point doesn't start until we get here. So at this point, this is f of 0. This would be g of 0. It's not true. Yeah, it is true. Okay, let's try this again. So for case 2, where c is some positive value, I think it's some positive delay value, we're going to start at some x equal to c. So you can see that if x were equal to c, f of c minus c would be f of 0. So on our original graph, this would be f of 0. This is going to be g of 0, which was equal to f of c minus c, right? Therefore, f of 0. So we've delayed the start. And it's going to happen this way for every value of x. It's going to be delayed by the value of c. So that will have a tendency to have a constant shift in time of a value of c. Notice that we are subtracting the c, okay, because x is a delayed start. Okay, x is a delayed start. Okay. If we look at the opposite direction, for case 3, I have a negative value. Now I am starting ahead. Again, I'm going to shift, but now in this direction. I will start early now. I will start early by the constant c. So again, I'm going to have the same shape, but shifted this direction. I'm going to have a negative delay or a jump start. All right, so let's do another example. We have the function f of x is equal to the absolute value of x. It's going to look like this. And then we want to use these rules to solve for what would g of x look like if g of x is equal to 2 times the absolute value of x minus 2, all of that plus 2. So to start with, our function f of x. That's what f of x looked like from over there. Let's go ahead and see what would happen if it was just 2 times f of x. Well, as we talked about with the first rule, this is a number that is greater than 1. It's going to skew us towards the y-axis. So this 2 being here is going to have a tendency to bring us in. So this is 2 f of x. That's what's shown in purple, 2f of x. Let me go ahead and label this as f of x. So let's see what rule 2 does. Rule 2 is going to have a positive value of a b shift. So that's going to shift me plus 2. So this is going to be f of x plus 2. So the shift caused by the plus 2 looks like this, just shifts up. So we start with our original shape, just shifting it up. Now let's look at our delayed rule. I have this x minus 2, so I'm going to have a positive delay. So this is going to take my shape and shift it to the right by 2 units. So that's going to look something like this. Okay, and then this would be f of x minus 2. So we put this all together, we have a shift to here for we shifted 2 units on the x-axis. We shifted up 2 units on the y-axis, and then we skewed inwards. So my g of x will look something like this. So this would be my answer, this blue function. You can see that I shifted it 2 units to the right, 2 units up, and I brought it in by a factor of 2. Thank you for watching my video. Please like and subscribe. If you have any questions that I can help you out with, I'd be happy to try and answer your questions. Send me an email at morelearnmoreteach@gmail.com.